Okay. So let's take a look at this stuff. So quadratics, we've worked with quadratics before, right? Where it's basically just our U shape or like our parabola shape. You know it's a quadratic because it'll always have your x to the power of 2. And then that's why it says your a can't be 0, because if you took it times 0, then that x to the power of 2 would go away. There's different parts of your quadratics that we're going to label. There's some pictures in your packet there that I'm going to do some labeling on. Your vertex is always either your high point or your low point, which would also qualify as your minimum or maximum. This is the little formula you use to find your vertex, and I'll show you that in the first example. And then once you find your a or your x value for that, then you just plug back in to find your y. Y-intercept is always at the C point, so whatever this C is, that's always your y-intercept. And then the x-intercept you got to do a little bit of work for. Do you guys remember using quadratic formula? So you use that quadratic formula to find your x-intercepts. And there's a picture of all this stuff in your package. You got to flip past the examples, but there's some pictures there. I'm just going to label the parts on our picture. So like that spot there and that spot there, those are our x-intercepts, right? And our x-intercept is always when our y is equal to 0. And then it's nice there they actually write out that you would use that formula and that formula there. That one's just plus and that one's just minus because that one's on the right side, that one's on the left side. But it's that same quadratic formula. Other things to note here, they've got your y-intercept labeled there as well. So that's your y-intercept, and your x is always equal to 0 there, and then they kind of show you that that's the same as whatever your c value is in your formula. And then the other thing to note here is if this is facing upwards, our a value has always got to be positive. So if our a value is greater than 0, it's going to open up or upwards. So if our a value, whatever it is in our formula, is bigger than 0, opens up. So then the bottom picture there is kind of like the opposite of that. So like if it was positive, it opens up. This bottom one here is opening down. So that would be when our a value is less than 0. Again, the a can't be 0 itself, otherwise 0 times x squared is nothing, so that wouldn't be helpful. But if our a is in the negatives, it would open downwards. And then they've also got the y-intercept labeled on this one too. So you can still have a y-intercept even though it's facing the other way. And again, our x is always equal to 0 there. And it's always the same as our c. And then there might be some situations where you don't have any x-intercepts, so that's why they don't label anything for x-intercepts here, because you know the x-axis is there, this one's completely below it. So you might have situations where there's none at all. And then they also label there like the vertex there is the minimum point, and then the vertex there is the maximum point. Okay, but hopefully most of that stuff's reviewed for you guys, right? Okay, so after you get that, then I think the next thing's our example. Yeah, so we'll jump to example 1 then, and I'll kind of show you how to find some of this stuff. Okay, so we've got our function f with the equation f of x is equal to negative 3x squared minus 4x plus 7. First thing they want us to do is find our x and our y-intercepts. So for our y-intercept, that one's easy. What do we look for with our y-intercept? What letter is important to us? Yes, x equals 0, and what else? If we put a 0 in there for that x and put a 0 in there for that x, what would that kick us out? 7, right, which would be our c value, right? So our y-intercept would be at 7, or if you wanted to write it as an ordered pair, yep, you could do it as the 0 for the x, 7 for the y. So that's the easy one. And then the x-intercept, that's where we got to use our quadratic to kind of solve that out. So for our x-intercept, we would go, it would be negative b, I should probably go through and figure out what our a, b, and c are, right? You guys remember how to figure out which ones are which for those? So a always goes with the x squared, so that'd be like negative 3, b always goes with the x, negative 4, and then c is always our constant, which would be the 7. So it's always negative b so -4, or the opposite of it, which would make it a positive, plus or minus square root of our b value squared, so -4 squared, and I'm going to put it in parentheses, so I remember to put it in parentheses on my calculator, minus 4 times my a value, which is -3, times my c value, which is 7, over 2 times my a value, which is -3. You guys have that formula memorized? Okay, I was just wondering. We had to learn a song about it when I was in middle school, so which has been very helpful because now I have it memorized. Okay, so then I'd start simplifying some stuff out here. So like I said, it's always the opposite of whatever our b is here. So since it was negative, that'll switch that to a positive. So that'd be like 4 plus or minus, and then we can do some simplifying in the square root. -4 squared, 16 minus, and then 4 times -3, -12, and then -12 times 7. Yep, -84. And then since it's subtracting my negative, we know that's the same as like adding in there, right? Over, and then what can the bottom simplify to? -6. Okay. And then I can keep simplifying under my square root, right? Because what's 16 plus 84? 100, which is convenient, right? Because doesn't the square root of 100 come out nice? Yeah, absolutely, right? What is square root of 100? 10. So then we'll have 4 plus or minus 10 over -6. And then me personally, this is where I then split it into like my plus and minus. What's plus and minus mean? Or plus or minus? Yeah, we do one where it's add and we do one where it's subtract, right? And we typically see this with square roots because wouldn't the square root of 100 technically, couldn't we put a 10 in there and square it, or a -10 in there and square it and still get 100? Yeah, so that's why we have to be a little cautious with that. So one of them would be like 4 plus 10 divided by -6. The other one would be 4 minus 10 divided by -6. So that'd be 14 divided by -6, which you could either reduce that down to -7/3, or you could figure out what that is as a decimal. Be like 2 1/3, something like that, -2 1/3. And then this other one here, 4 minus 10 would be -6 divided by -6 would be positive, or no, +1, yeah. Yep. Alright, so that was x-intercept. Like I said, that one's a little trickier. Okay, and then tell whether parabola has a maximum or minimum, and then find it. Okay, so maximum or minimum, that's determined by if it's opening down or opening up. So here, if it's negative there, where would it be? Would it be opening down or opening up? If it's negative. Down. So would that have a minimum or a maximum? A maximum, because the high point would be at the top, right? So for B, I would say that it has a max. Draw a little line there so I don't confuse what word goes with what. And then to find the vertex, the little formula that they give you is x is equal to -b over 2a. So you just take your same a and b from before. So like x would be equal to the negative, b would be -4 times the negative over 2 times the -3. So that would make that a +4, right? Over -6, which would be the same as -2/3. So then what that does for us is that gives us our x coordinate of our ordered pair is -2/3. And then to find the y coordinate, all you would do is you would just take that value and plug it back into your original function there. So I'd go like our y is equal to, or f of x, however you want to do it, -3 times -2/3 to the power of 2 minus 4 times -2/3 plus 7. And then I'd probably just straight up put that in my calculator and see what it comes out to be. It comes out to be a decimal or a fraction again. So I've got it as, of course that shuts off, I've got it as 25/3 when I put it in my calculator. So that would just mean our y coordinate there would be 25/3. If you put it as decimals too, that's fine, I don't care that much. The only thing is if you switch that to decimals, then it can make it a little harder there to do your plugging back in, but okay. Need a second before I flip. Okay to flip. Alright, so we got another formula here put in our notes. And you probably have done this formula before. Usually they do it in algebra as well, so I'm sure you've seen it before. I'm going to scroll out a little bit so you can get all of it. No, I can't get to it. There's only one more bullet to write after this. Get this one first, and you get that other one in a second. It's just the calculator steps. Okay, so like I said, you've probably seen this formula before. It's very common, quadratic one that they use. So it's always our height is equal to half of our gravity. Just with gravity, you got to be careful to look at the labels. If it's in feet, you use 32. If it's in meters, you use the 9.8. And then it's always half of that, so like 16 and 4.9 or whatever it is. And then T stands for your time squared, whatever that is, plus, so here, this is called, so it's V sub 0, but that 0 is always not. So how you say that is like V, and then I think it's like not like that. I don't know, I think it's from another language or something like that, but that always means like your initial of something. So if it's ever like sub 0 there, that's your initial, and then times your T again, plus, and then that would be like H naught. Again, having that little 0 there, but those are always initial values. Okay, so then back to our sheet here. So we're going to do one there with a projectile or something being thrown. So a projectile shot from a tower 10 foot high with an upward velocity of 100 feet per second. Approximate the relationship between h height in feet, t time in seconds after the projectile shot. When it says approximate the relationship, that's just an equation. So you're just coming up with an equation for that situation. So we don't know what our end height is, but we do know that it's always going to follow the pattern -1/2 times our gravity. What's our gravity in this situation? If we're in feet? The 32. Or you could just switch that to -16 right away if you wanted to. We don't know our time, but it'll be t squared, plus the next thing is the initial velocity. What's our initial velocity? The 100, yep, so 100 feet per second. So that'd be times our t, plus our initial height. What's our initial height? The 10, yep. So that'd be our approximate relationship, just setting up that equation. And then they want to know how long the projectile is going to be in the air. So what I would think here is I'd be thinking the same kind of formula. What happened is, so they're asking us how long it's in the air. When would it no longer be in the air? When it's at 0, right? Because that'd be like when it hits the ground. So it gets shot up, comes back down, hits 0, not in the air anymore, right? So we would just set our height to 0 there. Formula is the same, so you can go -16 t squared plus 100 t plus 10. And then me personally, since we have the capabilities of our calculator, I just use the calculator for this. You can do the plugging in and doing all the solving out, or use quadratic formula to find where it would cross there, but since we have the calculators, we might as well use them. So what I would do personally is I'd go to my y equals, I'd type that equation in, so like negative 16 x squared plus 100 x plus 10. I typed in. And graph it. So you can't see it very well, so you can either like try to just zoom it out, or you can go to specific zoom ones. I'm just going to try to zoom out and see what that does. Okay, so not great. So it's, you know, shooting up there pretty quickly. Probably could have done a different zoom to get a better picture of that, but you know, it's going up there, coming back down. So basically right here would be where it's hitting the ground again, right? So to find that, if you go, what do I got to go to? Second in that trace button, we want to calculate our 0 value here. So I'd arrow down to 0, hit enter, and then it asks that jargon about left bound, right bound. You just want to make sure your cursor is on the left side of that intersection point with the x-axis. Which I would already been on the left anyway, but I'm just going to get it closer. There it is. Okay, so now it's on the left. Enter. Get it below it to put it on the right. Enter. I don't know why it asked for guess, but enter again. And then here it tells us our x is equal to 6.348 something something, when our y is equal to. If it ever says something like this here, that means 0. Sometimes the calculator has a hard time like crunching these real tricky numbers. So if it's like some E thing there or whatever, that's as close as it could get to 0 with its rounding and that kind of thing. So I just put there our t would be approximately equal to 6.348 or something like that. And that'd be in seconds. So that's what I would do. If it doesn't specifically tell you to do it by hand or something like that, you can use your calculator. I don't care. That's what we got them for anyway. Okay. And then one more thing just to write down here. So the last thing is your calculator steps. It's all the same, except for instead of picking like exponential reg, you're just picking quad reg instead. But all the rest of the steps are the same, where you type it into your list and all that stuff. So I just jot those down just in case you forget them. Okay, so like I said, it's same steps as we did before, just hitting quad reg instead of expo reg, or lin reg, we did that one too. But you find it in the same place with the second and the trace button. Oh, or the second and the stat button. Okay, so we would go to our list. Oh, we should probably flip to the actual question we're doing this for. Okay, so last example here, example 3. They give us some points here that would be in a parabola. Technically, the book wants us to solve this out using systems of equations. I'm not too wound up about that. You can use systems of equations to solve this out, kind of putting in your stuff for like the x's and the y's, setting it up and doing solving for a, b, and c. I'm not going to worry about that. I'm just going to have us use quad reg here. Mr. Kasich told me to make you use matrices, but I already had this typed up, so I'm not going to make you do that. So let's just type it in our calculators. How about that? Alright, so we want to go stat And I hate matrices. You guys like matrices? I hate them. I hate all the typing in. Ugh. This is a lot of typing in too, I guess, though. Okay, so we would just type in all of these things here. Sometimes it's helpful to put like X and Y above them. So when you're looking back and forth, you don't have to like, you know, I don't know, just guess which one's which. But so I'd type all those into your list. Okay, and then once you get them typed into your list, just like we usually do, it would be stat, arrow over to calc, and then this time we're looking for quadrig, which looks like it's the fifth one. Hit enter. Mine's the old one. I didn't get my new calculator out, but if you have the new calculator, it'll say like L1, L2, and that kind of thing. You just pick L1 and L2. If you want to store it in the Y1, you can do that too. Mine just will do it for the first two. So if I hit that, it should come out with nice numbers this time, because these all specifically are on that exact parabola there. That's why our R squared there is 1, because it's a perfect fit, and that's why none of them are like decimals there. So then you would just take and write those into the spots. So like y is equal to our a value is -2, x squared plus our b value is 13, x, and then our c value is -15. Like I said, I'm not going to worry about the system stuff, but if you are interested in knowing how to do it with systems, example 3 in the book does that, but I'm cool with this. Okay? Alright, so that's it for notes here. So you got that book page. I crossed out I crossed out number 12 there just because it's kind of a lot going on with that one. And then also on 10B, that's the question on the assignment that asked you to set up the systems on that. Don't set up systems. Like I said, I don't care about that. Just do quadrig is fine with me for now. I'm cool with just that. So working on that, and tomorrow we'll move to the next section.